Have you ever wondered why some websites just pop onto your screen in a blink, while others, well, they leave you staring into the void? It's not luck, and it's definitely not magic. It's all about engineering. Today, we're going to pull back the curtain on the hidden rules of web performance, ideas that were laid out way back in a 2015 paper but are, somehow, even more important today.
Oh, we have all been there. You click a link and boom, you're greeted by that dreaded spinning wheel. That tiny, agonizing pause is exactly what we're going to tear apart today. Because that delay, it's not random, it's a puzzle we can actually solve. So, what is the deal with that spinning wheel? What's the secret sauce that makes one site feel instant and another feel like it's wading through digital mud? Let's get into it and solve this mystery together. Okay, so at the very core of nearly every website you use is a language called JavaScript. It's the stuff that makes pages do cool things. You know, animations, interactive forms, all that good stuff. But here's the catch. The way that JavaScript is written and delivered to your browser, that is the single biggest decider of whether a page feels fast or slow. This quote right here, it really gets to the heart of the whole problem. You see, with a lot of other programming languages, there are these smart tools called compilers that automatically clean up and optimize the code for speed. JavaScript doesn't really have that. The responsibility falls entirely on the developer. The code runs pretty much exactly as it's written, which means a really skilled developer can make a site fly, but a less careful one can accidentally grind it to a halt.
All right, our first major hurdle is super simple. It's the download. Before your browser can do anything, it has to get all the pieces from the server. And this is almost always where the first big traffic jam happens.
Think about it like this. When you request a web page, the server sends back a basic blueprint. That's the HTML file. But that blueprint is covered in notes that say, hey, you also need this file, and these other 20 files over here. Your browser has to go and fetch every single one of them. And each one of those little trips, no matter how small, adds a little bit of delay. And trust me, those delays add up really, really fast.
So how do we fix this mess? You group them up. It's like, instead of making 10 different trips to the grocery store for 10 items, you just write one list and make one big trip. Developers do the same thing. They combine all those little script and style files into just one or two big bundles. Fewer requests means a way faster start. And here's the next trick in the book, compression. Once you have those big bundled files, you can basically zip them up, shrinking their size by, get this, up to 70%. Smaller files means faster downloads. It's such a simple idea, but the impact it has on that initial load time is just huge. Okay, so the code has arrived. It's small, it's fast, we're done, right? Not even close. Now we have a totally different problem. How does that code actually run inside your browser? Because that can create its own massive bottleneck, like a single-lane highway during rush hour. This is the big one, folks. Script blocking. Your browser, for the most part, can only do one thing at a time. It's working on a single track. So when it starts running a big JavaScript file, everything else just stops. The page freezes solid, you can't click on anything, you can't scroll. Your browser is totally and completely occupied until that script is done doing its thing. And you can see the two worlds right here. On the top, with blocking scripts, you get this frustrating step-by-step freeze. It's awful. The solution, on the bottom, is to load scripts in a non-blocking way. This lets the page show up and become interactive first, while the heavy lifting happens in the background. It's literally the difference between a page that feels alive and one that feels broken. Now, another one of these silent performance killers is something called a DOM reflow. Just think of the DOM as the browser's internal blueprint of the website. Every time a script changes something that affects the layout, like say the size of a box, the browser might have to throw out its entire blueprint and redraw everything from scratch. It is an incredibly expensive thing for a browser to do.
This analogy just hits the nail on the head. Can you imagine the sheer amount of work it would take to redraft an entire architectural plan just because somebody moved a chair? It's nuts! But that's exactly what a poorly written script can force your browser to do over and over again. The best developers are wizards at finding ways to make changes without causing this massive recalculation. So our next big principle is maybe the most elegant one of all. It's the simple but incredibly powerful idea of not repeating your work. If you've already done the hard work to figure something out, why on earth would you ever do it again?
This is really the heart of it all. What's the fastest code you can write? Well, it's the code you don't have to run at all. If a complex calculation has been done once, or some data has been fetched from a server, the goal is to save that result somewhere. and just reuse it instantly the next time you need it. Now, the fancy technical term for this strategy is memoization, which really is just a clever way of saying caching or remembering. The code basically keeps a little notebook of its past work. So when you ask it to do the same task again, it doesn't do the work. It just flips open its notebook and gives you the answer it already found.
And this process is as simple and brilliant as using a sticky note. The first time your code needs an answer, sure, it does the math, but then it jots the answer down. From that point on, anytime it needs that answer again, it just glances at the note. Done. This saves a mind-boggling amount of processing power, especially for complicated stuff that a site might do all the time. So, we've gone on quite a journey, right? We've talked about downloading files, running code, and avoiding work. Let's pull all of this together and boil it down into a few clear, golden rules that really define what makes a modern website fast.
Here they are. First, load less, load smart. That's our bundling and compressing. Get fewer, smaller files to the user. Second, don't block the user. Let them see and interact with the page while the heavy scripts do their thing in the background. Third, minimize browser work. Avoid those super expensive reflows. And finally, don't repeat yourself. Use caching to remember the work you've already done. It's that simple.
So the next time you land on a website that feels buttery smooth and just instant, you'll know why. It wasn't an accident. It's because some thoughtful developer was carefully applying these exact principles. It's the invisible engineering that makes all the difference between a great experience and a frustrating one.
And that kind of leaves us with a big question, doesn't it? As our websites become more and more complex, basically turning into full-blown applications in our browser, do these simple fundamental rules actually become more critical than ever before? It seems like the quest for a faster web isn't just about convenience. It's a challenge that's here to stay.